Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with design of beams. So the singly reinforced beam. So the problem is design a singly reinforced beam to suit the following data. So the clear span is 4 meter. Okay, so the beam's clear span is 4 meter. Then width of support is 300 mm. Then service load is 5 kN per meter. Then M20 grade concrete and Fe415 steel we are using. Okay, so now we can take the stresses, that is FCK is 20 Newton per mm square. So then Fy is 415 Newton per mm square. Okay, so first step we can find out the dimension, that is the effective depth of beam. So after that we can find out the load. So first step is depth, second step is load, third one we can take the moment and shear. After that fourth step, so we can provide the reinforcement. After that check for shear. So these are all the steps we can use to design the singly reinforced beam. So now we can take the depth. So first thing is cross sectional dimension, that is a depth. So effective depth, so effective depth equal to span by 20. So basically we can take the span range of 3 to 4 meter. In the loading condition is light, so we can take the span by depth ratio as 15 to 20. So the span by effective depth ratio is 15 to 20. Okay, so 15 to 20. So here we can take the 20 value. Okay, so now solving this, so depth D equal to span is, we know span is 4000, that is 4 meter, that is 4000 divided by 20. So now D equal to 200 mm. So now we can take the overall depth with the cover, so that is equal to 50 mm cover, so that is 250 mm. Okay, so next thing is B. So B is 200 mm. So width of beam is 200 mm. So now we can calculate the effective span. So effective span equal to, so now we can take the clear span plus effective depth. So that is clear span is 4 meter plus effective depth is 0.2 meter. So that is equal to 4.2 meter, that is equal to 4200 mm. Okay, so another thing is we can take the center of supports. So that is equal to 4 plus 0.3. So the support is 300 mm. So here we can take the 0.3 divided by 2 plus 0.3 divided by 2. So that is equal to 4.3 mm. So 3 meter, that is equal to 4300 mm. Okay, so now we can take the effective span as 4200 mm. So next thing is we can calculate the load. So now the load calculation, first thing is self weight. So self weight of beam, that is equal to B into D into gamma of concrete. Okay, so that is equal to B is 0.2 meter into D is 0.25 meter into gamma value. So gamma values, unit weight of concrete is 25 kilonewton per meter square. Okay, so we are solving this, we got the value of 1.25 kilonewton per meter. Okay, so here is kilonewton per meter cube. So meter cube and meter cancel, so only kilonewton per meter. Okay, next thing is live load. So live load is given, that is 5 kilonewton per meter. Okay, so next thing is total load, we got the value of 6.25 kilonewton per meter. Okay, so now we can take the design ultimate load. So design ultimate load WU equal to 1.5 into 6.25. Okay, so 1.5 is the factor of safety. Okay, so solving this we got the value of 9.375 kilonewton per meter. Okay, so this is the WU value. So next thing is we can find out the moment. So now the moment U equal to WL square by 8. Okay, so now we can substitute WU is, we know, 9.375 into L square, so L is 4.2 square divided by 8. Okay, so solving this we got the value of 20.67 kilonewton meter. Okay, next thing is shear stress VU is WL by 2. Okay, so now 9.375 into L is 4.2 divided by 2. So solving this we got the value of 19.68 kilonewton. Okay, so this is the moment and this is the shear stress. Okay, so next thing is we can calculate the under reinforced section or over reinforced section. So now we can take the MU limit. So MU limit equal to, the formula is 0.138 FCK V into D square. Okay, so for M 20 grade concrete and FE 415 steel, we can use the MU limit as 0.138 FCK VD square. So now we can substitute all the values over here. So MU limit equal to 0.138 into FCK is 20 and B is 200 mm into D is 200 mm square. Okay, so solving this we got the value of MU limit equal to 22.08 kilonewton meter. So now we can take the MU value. MU is 20.67. So now MU limit is 22.08. So hence it is under reinforced section. Okay, so now we can find out the reinforcement. So MU is, the formula is 0.87 Fy AST into D into 1 minus AST into Fy divided by FCK BD. Okay, so now we can substitute all the values over here. So MU equal to 0.87 into Fy value is 415 into AST we have to find out into depth is 200 mm into 1 minus AST is we have to find out into Fy value is 415 divided by FCK value is 20, here is 200 into 200. Okay, so now solving this we got the value of AST equal to 350 mm square. Okay, so this is the area of reinforcement. So now we can provide 3 bars of 16 mm dia. Okay, so now the corrected AST will be 402 mm square. Okay, and 2 hanger bars of 10 mm dia. Okay, so this is the area of reinforcement we can provide. So the another step, the last step is check for shear. So now the check for shear. So now we can take tau V equal to VU divided by B into D. So VU value is 19.68 divided by B into D. So B is 0.2 and D is 0.2. So now we convert into all this into Newton per mm square. So 19.68 into 10 power 3 divided by 200 into 200. So solving this we got the value of 0.49 Newton per mm square. Okay, so now we can find the PT value. So PT is 100 AST divided by B into D. Okay, so now we can substitute the 100 into AST value is 402. Okay, so divided by B into D, so that is 200 into 200. So now we got the value of 1.005. So this is the PT value. So now we can refer table number 19 in is456. Okay, so code to read out the permissible stresses. So the permissible stress tau c equal to 0.63 Newton per mm square. Okay, so this is the greater than of tau v. So the provide the shear reinforcement using 6 mm diameter of two regular stirrups. Okay, so now two-legged stirrups we can use in the spacing of SV equal to AST into 0.87 Fy divided by 0.4 into B. Okay, so now we can substitute 2 into 28 into 0.87 into 250 divided by 0.4 into 200. Okay, so solving this we got the value of 152 mm. So adapt spacing 150 mm centers. Okay, so this is the method we can solve the problem. Again we will see next video. Thank you.